So good afternoon. My name is Beena Sukumaran. I'm the Dean of the College of Engineering and Computing at Miami University. I know for some of you it's still morning and for some of you it's nighttime. So wherever you are, thank you for joining us. This is the second in a series of lunchtime, at least lunchtime here, alumni webinars. So welcome to our alumni who range all the way from our 1967 graduates to our most recent. And today's focus is actually on socially engaged engineering and computing. We love our acronyms, so we call it SEEK. SEEK is a hallmark of the College of Engineering and Computing, and the reason it is so is we wanted to emphasize the social impact that engineering and computing professions have. So everything that we do in engineering and computing has a tremendous impact on society and the well-being of our communities. So through SEEK, we offer students the opportunity to engage in this firsthand. So our students can actually minor in humanitarian engineering. They can get involved in projects that benefit humankind. And two of the hallmarks of this program, we have two hallmark programs under the umbrella of SEEK, one of which is our Miami University Center for Assistive Technology, or MuCAT, and the other one is a Grand Challenges Scholars Program, GCSP. And who better to learn about these hallmark programs than from our faculty and students? And so I have the distinct pleasure today of introducing two of our faculty members who head these programs. Dr. DJ Rao from our Computer Science and Software Engineering Department, and Dr. Jim Chagdes from our Mechanical and Manufacturing programs. They're also joined by two of our students, John Liu and Logan Coca. And Jim and DJ will be introducing them in more detail later. So DJ, I'm going to start with you and the Grand Challenges Scholars Program. So I guess before we get started, so if you have any questions, please do share your comments using the Ask a Question button in your wherever you're viewing it. So please do ask questions because this group would love to get questions. So as I was saying, I'd love to start with the Grand Challenges Scholars Program. And the reason we're doing so is because Logan has a class that's starting at 12:40. This is our first week of classes. So it's, she definitely has to make it to her class. So DJ, can you describe for us briefly the Grand Challenges Scholars Program?
Sure. Thank you, Dean Sukumaran. Welcome everyone to this alumni get-together. We're doing it, of course, COVID style. I would have loved to be able to see all of you here in person and share some of our thoughts here. But we're doing it COVID style, and but still I can feel your presence in spirit. So that's an awesome feeling. What I would like to do is, I have a few slides, not a whole lot, I promise you, just 5 slides is what I have. And I would like to share those 5 slides with you so that, I can highlight all of the student accomplishments and give you all a quick background on the Grand Challenges Scholars Program. So I'm gonna go ahead and share my PowerPoint screen with you folks. And hopefully you guys are able to see my PowerPoint presentation. Yeah, can somebody give me a thumbs up just to make sure I got it? Awesome, yeah. Let's start here. I don't know if you guys are still able to see. So the Grand Challenges Scholar Program is meant to be a transdisciplinary STEM program. So it is science, technology, engineering, and mathematics. And the idea is it is designed around themes that are focused on advancing some of the complex issues that we face in our nations today. So there are several themes that the students are working on. We like to call them scholars. And so So in terms of the scholars, we work with engineering better medicines. We also focus on cybersecurity, advancing health and informatics, and engineering better tools for scientific discovery. So the scholars are working on different areas that they are passionate about. It's open to all undergraduate students, and we look for competencies in several different areas, like in terms of computation, entrepreneurship, societal and global perspectives, leadership, and mentorship and service. So we would like to have all of these different areas come together that collectively make our scholars as part of the Grand Challenges Scholars Program. So we're looking for the well-rounded individuals who can bring science, society, entrepreneurship, everything together to make that comprehensive solution to address some of these complex challenges that we are facing today. We currently have about 39 scholars in our program from different majors. As you guys can see, there's like a broad spectrum of people who are interested in this Grand Challenge Scholars Program. We have students working in different areas, sustainability being one area of interest, and healthcare and better medicines being another big area of interest. But we have students working in different areas. And one of the interesting parts of this Grand Challenge Scholars Program is we have a very healthy proportion of men and women who collaborate and work together on a lot of these projects. And so clearly this program is attractive to men as well as women equally. So we love that balance. We love that 50-50 kind of a balance in terms of gender in this program. So that is something that tells us that we are doing something right in terms of exciting our students and involving them in these types of socially engaged programs. And of course, we have students in different graduation years that are going through this program as well. So we have several competency areas that a lot of the students are working on. And then we have several capstone projects that students work on. So here you guys can see a picture. The dean is also here. Dean Sukumaran is here. This was our first COVID-style socially distanced picnic. The students really wanted to do something in person. You know, we were talking all the time on Zoom and doing the video presentations. We finally really wanted to get together, so we had this small picnic. A few of us got together. Particularly, this is the leadership team there that thinks about it. And we have students who are working on green energy and reducing pollution. We have students working on urban infrastructure, working with like bike rack designs and such. We have students working with solar energy. So now they are trying to do a solution for the city of Denver in Colorado. So they're working with companies there, trying to get solar deployed in Denver, Colorado. And then we have several projects here. We have one of our scholars, Logan Coca, with us, and I'm going to let her talk more about her project as well. In terms of alumni involvement, this is something that we have. The Grand Challenges program, in terms of the leadership team, has been discussing this very actively. We are eagerly hoping to get alumni involved in our program in different ways in terms of short guest presentations. When we say presentation, it doesn't have to be something formal that you put together. It's more of a conversation with our students to give them ideas, give them some mentorship, give them motivation. So many different ways that you can contribute to the spirit and the theme of this effort. And of course, project ideas, like if you have interesting project ideas that you feel are important, or there is something that is of interest in your disciplines, then those ideas are very welcome, and those would be very interesting ideas for students to work with. And of course, connecting students with opportunities, maybe at your organizations, there are some interesting opportunities where students can apply for those opportunities, or even just do some job shadowing opportunities. You know, many of you might be working at very interesting organizations, and sometimes just watching or tagging along with your work for half a day would give students so much more experience and given them an insight into how the industry, whatever is the industry you guys work in, how those industries work. So if any of you have some time and opportunity to engage with us on these areas, we would be extremely happy to work with you and take advantage of your awesome experience, your awesome skill set, so that the students can utilize those and build their own skill sets. With that, I'm going to stop. Thank you all for your time to watch this presentation. I'm going to hand it over to Logan so she can talk a little bit about her experiences with the Grand Challenges Scholars Program. Logan, it's now your time.
Thank you. So I'm going to start out telling you why I chose to join, because I think that's important in the timeline. I chose to join the GCSP because I thought my career goals really aligned with the goals of the national academies who actually run the program. The GCSP is centered around solving the world's greatest challenges and equity and real disruptive innovation. And I thought I have to be a part of that. And I think the skills I'm building through this program, as well as the networks built, will allow me to make an impactful difference in my area of study, which is genomics. Through this program, I was the first Miami student to enter into the Global Grand Challenges Summit, which is a global hackathon held every 2 years. It's hosted by the NAE, the Royal Academy of Engineering, and the Chinese Academy of Engineering. So students from all 3 countries actually come together and compete, and it's really awesome. I led a team of 2 other students who were actually interdisciplinary, so they were not engineering. We had a microbiome student and we had a business student. So that was a cool experience working with students outside of my college. I was the team leader, and we proposed a cheap insulin alternative using spirulina as the active ingredient, which is a type of cyanobacteria, or think of algae. We pitched this first in DC. We placed top 8 in the nation. And while we didn't make top 5 and we didn't pitch again in the final round, we were invited to attend the pitches in the rest of the conference in London in the UK, which was an amazing experience. The first time I got to go outside of the United States. The most impactful and lasting part of that experience was actually not the technical skills that I learned through research. It was the amount of inspiration and excitement that I felt from seeing other young people from all over the world passionate about the same things that I am. Later, I entered into a COVID-themed hackathon through Johns Hopkins, which was on Dr. Rao's slides. The teammates for that hackathon were students I met in London. We still keep in contact. We won the hackathon with a hands-free door opener design back when it was still novel. And we were also highlighted by the NAE during one of their technology showcases. Projects we have going on right now, for me at least, the MuCAT is kicking off, which you will learn about later. And I've convinced 2 other GCSP students to do it with me, so that will get started here soon. And then I've also been doing some osteosarcoma research, which is a gene-wide association study related to who goes into remission after treatment and who doesn't. And I'll pass it back to DJ Rao, or the dean.
Thank you so much, Logan. You did awesome. Dean Sukumaran, that was the summary from the Grand Challenges Scholars Program.
Sure. I am constantly awed. I met, I think Logan was one of the first students to reach out to me because she wanted to figure out a way to do her co-op as well as her schoolwork and so on. And then I got to meet her in person during the Grand Challenges Scholars Program picnic. So thank you, Logan. Thank you, Dr. Rao. Next, I would like to introduce Dr. Chagdes, who is going to tell you all about Miami University's Center for Assistive Technology. So, Jim.
Yep. Thank you, Dr. Sukumaran. Excuse me, Sukumaran. So I'm got the pleasure today to discuss with you MuCAT, our Center for Assistive Technology. And first, I'll give you a brief overview of the center. So the center really is a cross-disciplinary research center, which was really established to enable technological solutions for socially relevant problems. So the center aims to improve the quality of life of individuals, and that can be anyone from older adults to people with disabilities. And the goals of this center really are, one, to advance the knowledge through these research activities in the broad area of healthcare and assistive technology. But some of the other goals that go along with that is really what we like is we're trying to produce next generation scientists who are capable of generating these technological solutions to address these different needs in society. Another thing or a goal that we have really is to enhance the ability to recruit high caliber women and unrepresented segments of society. We really feel that this center has been moving in that direction, and we're really excited of what's to come in the future. I'm going to also share my screen with you to show you a little bit about the number of people that are in our center. So the current members, a part of MuCAT, are shown here. There's really 18 faculty members with the pictures shown here. And just to give you a little bit about the profile of the participants, these 18 faculty members really are across 4 Miami University divisions. So as you can see, and again, we do have many acronyms. They come from the College of Arts and Sciences, the College of Creative Arts, here within the College of Engineering and Computing, but also EHS, which stands for Education, Health, and Society. So really 4 different colleges have come together, or different participants of these colleges, to work on these socially relevant problems. And you can see also we have over 60 undergraduate students working on some related project within MuCAT. Of those undergraduate students, 40% of them approximately are females. We have graduate students, over 15 graduate students working on these projects or research projects, and about 45% of them are female. So the next slide here that I'd like to show is a little bit about some of the projects that we do cover. So these multidisciplinary teams are really solving many different complex problems. So some of the problems that we look at are in the area of rehabilitation robotics, dealing with human balance or other type of rehabilitation, looking at redesigning things such as the walker, or using new technologies like virtual reality to be able to put people into new environments to help rehabilitation. Some of the other things that we have are really looking at medical device design. How can we redesign medical devices to be used in surgery or drug delivery? How can we model, for example, the nasal cavity or passages and be able to efficiently get drugs to a person and effectively help them? We also have some looking at pressure ulcer prevention, looking at biomaterial implants, such as knee implants, and then tissue generation or tissue engineering. How can we help people, for example, with osteoporosis to be able to strengthen the bone material? So these are a few of the cross-disciplinary projects that we have going on, and these are just a few. We do have others as well that we're excited about. And one of the other things, a part of our center that we are proud of, is our ability to involve undergraduate students. And I'm going to let John, our undergraduate student here, talk in a moment about this. But really, we have what we call our design innovation competition, which is really a competition for undergraduates to be able to participate in the design process and try to solve really a socially relevant problem that improves the quality of life of individuals. So with that being said, I'd like to introduce John Liu. John is a senior in the Department of Mechanical Engineering. He's majoring in mechanical engineering. He is also a minor in the School of Business. So he is a student who has been a part of the center for a couple years now. He's also a part of our 4+1 program. So for those of you that might not be familiar with the 4+1 program, it's really a relatively new program which gives students the opportunity to work towards their master's degree while they're also working at towards their undergraduate bachelor's degree. And John, being a senior, is now in the point at which he's working or taking classes that are at the undergraduate level, but also some that are at the graduate level to get moving on that master's degree. So with that being said, I'd like to give John the chance to talk a little bit about his experiences with MuCAT.
Thank you very much, Dr. Chagdes. So a little more on the MuCAT. I think I joined my first and second year of college. And like what kind of like motivated me to join MuCAT is it's like a great opportunity, and it's also very inclusive to anyone from all grades, being like a freshman to all the way up to like a senior. And the reason why like MuCAT's so effective, I believe, is because you're kind of like surrounded by teammates that are all like supportive. And it's really just kind of like, you know, you're able to let your creativity show and design kind of products where people might have not necessarily thought like that before, and come up with like solutions, you know, that are affordable and efficient to like the consumers. And so like basically what MuCAT allows is it gives engineering students from like basically all grades, and it allows them to develop their professional and technical skills. And so I know coming into freshman year, I didn't really have too many the engineering core classes under my belt, but I was still given the chance to compete in this competition. And not only did I learn a lot more than I did from a lot of my classes, but it teaches you kind of like the design process of building, you know, from start to finish of final products. And so not only does it do that, it gives like students kind of like the opportunities to channel what they like have learned already from the classes to create like a tangible product, and basically going through the whole design phase, which is very uncommon until you're typically a senior going through senior design. And one of the other great things about this competition is after you finish with your whole product and design process, you actually get to go to like you're in the same fair as like the other seniors, and so you get to kind of like, you know, see what other people are doing as well, and they can also see like, you know, what you guys did for your project that year. And on top of those things, it's also great for like, you know, developing like resumes, especially if you're like a freshman, you know, and be able to go to like career fair and talk about some of the experiences that you got to do and help with others. And so like basically my first year at MuCAT, I kind of worked on designing an automatic life jacket where we're trying to make it more convenient for people to wear life jackets while like, you know, under the same comfort and fashion as like, you know, and prioritizing safety, of course, for the people that wear them. And so we got through the whole design process and design phase, and we ended up getting a finished product. And so like that experience, you know, I know when I went to career fair the past semester, being able to go to like, you know, like a medical companies, like, you know, and be able to talk about like, you know, the products that I got to design. It really shows like initiative as well, you know, as well as, you know, like kind of leadership skills, and like, you know, it shows that you can work together on a team. The second year at MuCAT, I actually got to design, or I didn't get to finish, but we started the design of like an automatic toilet seat, which basically helped people with like arthritis, kind of like with the knee problems, being able to sit down and get up from the toilet seat without having, you know, too many issues. And of course, though, like there are designs and solutions already on the market, but of course the prices is not quite affordable to like, you know, the common consumers. And so the big part of our project was trying to make it cheaper and thinking of different ways to raise and elevate the toilet seat, in order to like, you know, produce an easier method for especially seniors and people with bone problems to, you know, operate on the toilet. And so basically, like due to COVID, our team only made it through the design phase last spring, but it was still a great opportunity to, you know, go through just the process of design and prototyping and just going through the stage cycles over and over again. I think it has a really big impact for like, you know, people that don't have experience and like people that already have experience, kind of building up on the knowledge that they already have. And yeah, I think that's pretty much it. But I'll turn it back to Dr. Chagdes.
Yeah, thank you, John. So if we have time, we could talk more about the details of this competition, because it really is exciting what the students are able to do in really only one semester of work. Thank you for letting MuCAT, and I'll turn it back to the Dean.
Thank you very much, Jim. And thank you very much, John. I think, having seen Logan and John present, you understand why we come to work every day. It's because of them. I mean, they are an inspiration to us, and they do combine all that we talk about, right? Our IQ, imagination, ingenuity, impact. I think they embody that every day. So we do have quite a few questions, and actually I will post the first question to Logan because she is under a time constraint. So, there was a question about how does the hands-free door design work, Logan?
Great question. So we wanted to make a door opener that was accessible for maybe populations without access to electricity, as well as those with access. So we made it mechanically operated, no batteries, no power source. Basically, the structure was aluminum. It just stuck with adhesive to the bottom of a door right under the handle. And then there would be a cord or a wire that would run up to the handle that would also attach to the handle. And then you would just insert the toes of your foot or your shoe into the structure. You would lift up a little bit and pull back, and just the friction would allow you to do that from your foot to the structure. And then you could just get your elbow in and open it from there. We were thinking it would work best with doors with obviously like a lever handle or even a knob handle, and also doors that had the auto close function.
Thank you, Logan. And for those of you who have additional questions, please do put your questions in that ask a question that you see on your screen. We do have a long question, and I'm not going to direct, any of you can take it. So technology is changing at a rapid pace, facing huge challenges to universities that are trying to teach our new students to be ready for the job market. So analytics, cloud, new software languages, new software architecture, security and engineering tools, policies, etc. So how do you see Miami University's, I guess, CEC differentiate itself from other schools to help undergraduates be prepared to be competitive in this job market when they graduate? Probably for the two faculty members, and then I'll also chime in. I'll let you go first. Who would like to start? Okay, DJ.
I thought I'll take it because it seems so much more on the computing side of things in terms of analytics, cloud, and new software languages. I want to give a response from the College of Engineering's perspective, as well as from Miami University's perspective, because I feel we are on a journey, a multifaceted journey in terms of the technology landscape that we have. So the question here is covering multiple tiers, multiple layers of the technology stack that you're asking. At the College of Engineering, we are, particularly in the computing side, we like to focus on the core, what you would call the infrastructure. That means, think of it this way in terms of you need somebody who's able to build the systems, like the lower level systems, right? Somebody has to maintain the operating systems. Somebody has to build the compilers and the web browsers and all of the other tools that enable these technologies, right? That is where we are trying to have that forte in terms of the computer science and software engineering. You come for a 4 or a 5 year degree, like a combined program. That means you are going to be building the engines of this race car that you're talking about. Because when somebody's going to step on the gas, You want that puppy to go. And CSE majors are the ones who will be able to build that web browser, build the compilers, work at the hardware layer and the software layer in the College of Engineering. We build a race car, right? Once we build the race car, our students are not interested in driving in crazy circles and circles on a racetrack. That we handed off to the other colleges. So in the College of Business, in the College of Stats, is where we think of them as our clients. That means we build the software systems, and they are our clients who then start applying those algorithms and data structures and software systems for different kinds of analytics, maybe business analytics, maybe data analytics, applications of machine. We build the machine learning algorithms, and the stats and the business people use our algorithms to do the actual business problems or solve business problems. So that is where we are seeing the series, like starting at the core and working our way all the way to application. And students pick, and this is a continuum. I do not want you to think like it's a heads and tails, two sides of the same coin. Yes, we want to mint coins, both sides. So one side is the computing, the core, another is the application, but we have students who are interested in the middle, like helping make the bridge between the engineers who are talking these compiler and other lingo, and the business people, the medical people, the psychologists, the sociologists who are speaking a different lingo. So we need students who are the bridge, who help bridge these different areas. So we have students in that discipline, in that spectrum as well. So almost a continuous spectrum of technologies. And this is how we at Miami, we are starting these transdisciplinary programs. That means we no longer just think of ourselves as silos, and we are trying to expand and have this continuum of classes where we are able to help students pursue their passions and figure out where they lie in this spectrum, right? Whether you want to be hardcore in the engineering, whether you want to go more towards the application. That slider is in the hands of the students, and they are sliding that with classes, with their projects, with things they want to do, and they follow their passion. And this is what I feel Miami is really turning out to be. I sometimes almost think of Miami also, it's lunchtime, as a buffet. So we have all of these choices, so many amazing desserts. And then we have our students come taste a little bit of these, and they say, ooh, I like this one. I want to eat more of that one. And they go in that direction. So that is the kind of educational experience that I feel we are headed towards in the College of Engineering.
Dr. Chagdes, did you want to add anything to that?
Sure. Yeah, I'll add a couple of points. So I'll give 1 point more on the research side, since I deal more with the center, which is really research focused. But I will also point out a couple other things that are, I think the college is willing to make investments in their future. And I think that's really shown through the development of a new major like the robotics major. So for those of you that aren't aware, starting in fall 2021, there is a new robotics major for undergraduate students, which really gives students the opportunity to explore these different automated systems. From the research side, one of the things that I've noticed is our collaborations with industry or federal agencies or the Wright-Patterson Air Force Base. I personally was able to get a couple students involved with research at the Wright-Patterson Air Force Base who are mechanical engineering students, but worked on really data analytical problems. So we looked at new technologies or data analytics, such as a topological data analysis, something most people aren't aware of. But really new ways of looking at big data to solve problems that we see in many different types of systems. So I think it's really through these different opportunities that undergraduate and graduate students are able to learn these new technologies and being able to apply them later on in their career. Excuse me. So that's kind of what I've seen. But I think also the college and the university's ability to invest in education and thinking outside of the box of maybe some traditional programs that we've looked at in the past.
Thank you, Dr. Chagdes. In fact, I actually wanted to open it up to John and Logan as well, because I saw some very interesting insights from them. So who would like to go?
I can go first just because I have to go in a couple minutes. So my comment was, I think on LinkedIn that an alum made a very large donation, and we are now getting ready to build a brand new data analytics departmental building. And I assume that the curriculum and the projects going on will also be elevated along with that building. So thank you to whoever, if you're out there watching, thank you. We love data here. And I'm actually going to hop off. So thank you for having me.
Thank you, Logan. Thank you for joining us. And actually, for those who are on the call, that building, in fact, will house our CSE department. Our computer science and software engineering department will be housed along with emerging technologies in business and design. I think it's ISA, and I forget what that acronym stands for, but it will house that department. So it will be a multi-college, multi-department building, which will just allow for some of these synergies. John, did you want to add something to that response as well?
Yeah, so I can't talk too much about the data analytics side, but since I'm mechanical engineering, I know a big thing that Miami has to offer is a lot of like research opportunities and clubs and activities on campus. And so I'm involved, unfortunately, I'm involved in both. And for research, I'm currently doing on research on conjugate cooling effects, basically in aerospace. And obviously, we know like research isn't like, we're not researching something that's already been done, but we're trying to like, hopefully lead to like publications and do like things that, people have not seen yet. And so currently I'm working with people at AFRL, which is the Air Force Research Laboratory up at Dayton. And we're basically working on designing basically a tunnel that can give us actual experimental data on some effects if we had like certain pressures and mass flows. And so I think it's a great opportunity for people if like, if students were interested, I think a lot of professors are willing to take like a lot of students, rather like some bigger schools, it's very competitive where, you have to be like on a wait list or you need to have certain like requirements. I basically hopped on like my second year of college and, I think it's a great opportunity for a lot of people. Regarding like clubs and activities, I know we have like an AIAA and ASME and a lot of these organizations where basically you get to meet like some older people. It's a good mix of all groups of grades. And AIAA, actually, we're joining like a rocket competition, hopefully this spring, where we're basically designing like a rocket from scratch. And so like as like a younger member, you get to learn a lot from like the older members and like, how to actually apply some of these like theories that they're learning and kind of like getting like the real world, like, relevant applications as well, which hopefully leads to like, future job and careers down the line. But yeah.
Thank you, John, for that very valuable perspective. So there was a question, and this is definitely for the faculty. Do you still have modeling classes, such as stochastic modeling, deterministic modeling? Who would like to?
I'll let DJ start from the computer side and I'll talk about mechanical in a minute.
We definitely do. And my research is on modeling and simulation, though I do a lot more on the large scale epidemic modeling and simulation. So we even now have classes on parallel simulation, agent-based modeling and simulation. So now we do continue to have what you would think of as classical systems analysis and design for the alumni who graduated from the earlier department name. We have continued to retain it, but it's got slightly different names. I mean, the math hasn't changed, I think, for the last 150 years. We're still doing the same differential equations. So don't get your hopes up here. Whatever Newton did, you're still doing the same things, but just slightly in a bigger scale and more interesting applications.
And I think that answered the question. Unless there's a follow-up question, I think that's sufficient.
So there was a question about where the new analytics building will be built. In fact, it will be right adjoining our Benton Hall. So it will be right here in the space. So it is very close to our current building. And so we see it as a whole complex here. And the reason they did that is they have created like STEM clusters, and we are part of that STEM cluster. So this analytics building will be right here. With that being said, I don't see, oh, yes. So the next question, are there other innovative new programs being considered? And I can answer some of this, and I'm sure my colleagues can join me as well. We do have a master program in clinical engineering that we are in the process of developing right now. And it is coming from a chemical, paper, and biomedical engineering, but this is, again, going to be a cross-disciplinary program. And it is to actually train technologists for hospital settings or for the medical device industry. So one would be handling, so there will be a specialization in regulatory affairs, so that will be one track, and the other track will be focused on the hospital industry. We also have some BA programs that our computer science and software engineering department has proposed. So there is going to be a BA in computer science. We thought it was critical that we did that because of our liberal arts foundation that we have at Miami University that all of you value. So that is our rationale for the BA in computer science. The same department, computer science and software engineering, is also proposing a BA in cybersecurity. And this is actually being done in conjunction with our IT folks on campus, so being very applied to serve the industry. And from Dr. Chagdes' department, we have a certificate program in automation and industrial manufacturing. So these are stackable graduate credentials that folks can, stack up towards a graduate degree if they so choose. So those are some of the new programs that we are contemplating. And I don't see any. So Michael, just let us know that there are no other questions. Did any of you want to add anything in closing? I guess in closing, let me say, because I think we are close to our end of time, I would like to thank our alumni who have joined us today. And I wanted to also remind you that the next event in this series will be on March 18th. Or maybe there might be a week off. We are still finalizing the date, but the anticipated date is March 18th. It will actually be a conversation that I will have with Professor Tom Shaber, who retired from Miami, and one of our alumni and director of the Lockheed Martin Leadership Institute, Ms. Louise Moorman. So we will have a conversation about the systems analysis program and how it has evolved over the years to our computer science and software engineering program. So thank you all. Thank you for joining us, and hope to see you at the next one. And thank you, John. Thank you, Dr. Chagdes, Dr. Rao. Thank you for joining me on this very exciting and I really loved learning about the program.
Thank you, everyone. Bye.
Thank you as well.
Oh, take care, everyone.